Howdy! In this video, we're going to find trig ratios, 5 of them, given 1 of them. All right, so we are given in this problem that tangent of theta is equal to 2 over 3, and we are given what quadrant it is in, which is necessary because tangent is positive in both quadrants 1 and 3. But that tells us, okay, we're in quadrant 3, so if you like to draw a picture, you can. I'm going to draw a circle here, which isn't really required, but probably used to it. So in quadrant 3, that's down here. I'm just going to draw it kind of in the middle. Don't know exactly where it is. That's okay. All right. Now, and when we draw a triangle to do trig on the XY plane on a circle, we're going to always draw that line straight up or down to the X axis. So what this is telling us is that for this angle, I'll put the theta right there. For that angle theta, we use this reference triangle, and that tangent of theta is equal to 2 over 3. Now, x and y, however, are both negative in quadrant 3. So I'm going to label this side of the triangle as -2, which is the x, and no, tangent of theta is y over x, so that's -3, and then this is -2, right? Because tangent of an angle theta in general is equal to the y divided by the x. In this problem, we are given that it's 2 over 3, but since y and x are both negative in quadrant 3, we know that this must really be -2 over -3, and that those negatives have canceled for the tangent ratio. Now, from that, actually, without all that, we could pretty easily find cotangent because cotangent of theta is just the reciprocal of tangent. So cotangent of theta, the reciprocal there would be 3/2 because it's x over y. And maybe I'll write that in there. That also, just for note, equals to x over y. Okay, now the other 4 take a little more work because the other 4 trig ratios, sine, cosine, secant, and cosecant, all require the hypotenuse. So we need to find the hypotenuse here. All right, so I'm going to do that in, how about in blue? We'll call that h. We need the hypotenuse h, okay? For that, we can use Pythagorean theorem. Whether you use positive or -2 or 3 doesn't matter. Either way, we're going to square it. So 2 squared plus 3 squared, one leg squared plus the other leg squared equals the hypotenuse squared. 2 squared is 4, so 4 plus 9 equals to h squared. So h is the square root of 13. Okay, now we can find the rest. So sine of theta is equal to the ratio of y over the radius or hypotenuse. I usually use r for radius, so I'm going to mark it that way and call this r. I'll just relabel this. This side you could call it r or h for hypotenuse. Either way, r or h. There we go. So that ratio, though, is the ratio of y, which is -2 over the hypotenuse or the radius of that circle, which is square root of 13. If you need to rationalize, then you would then, if that's not okay, I'm going to go ahead and box that as an answer. But if you need to rationalize, we would then multiply that by root 13 over itself. And so this would become -2 times root 13 all over 13. Okay, so that is equal to sine of theta. All right, now let's go ahead and do cosecant theta next because that is the reciprocal of sine theta. So cosecant theta is the radius over y, or it's the reciprocal of sine. I'm going to flip the unrationalized version. That way my answer is automatically rationalized. So that would give us root 13 over -2. It doesn't really matter whether the negative's on top or bottom. I just kept it with the 2. Okay, there's cosecant. All right, next we have cosine. Cosine of theta in general is equal to x over r. The x coordinate in this one is -3, and the radius is root 13. If you can answer unrationalized, you may stop there. But if you need to rationalize, we'll multiply by, just like we did with sine, root 13 over itself to get -3 times root 13 over 13. And last but not least, so let me box that answer up there. Okay, last but not least, we do have secant. Secant is the reciprocal of cosine, or r over x. The radius is root 13, and the x is -3. That's what we get if we find the reciprocal of the unrationalized version of cosine. So there is, oh, my head's in the way, I'm part of that. There we go. There's the how to find the other 5 trig ratios given one of them.